Okay, I'm back. Hopefully those 4 problems weren't too difficult for you. If you're still struggling and you want some more help, make sure that you come see me after Memorial Day weekend and get some help. All right, so now second podcast here is about how to solve these same types of limiting problems, except this time we're going to use grams. So let's go through an example to actually learn how to do this. We're going to follow the same 4 steps. You can see those 4 steps on your notes. You can see the same example problem in your notes. Write it down as I do. So we're going to start taking a look with the reaction that occurs in rocket engines. And we've got some liquid hydrazine, which is N2H4, and hydrogen peroxide, H2O2, and those are used as propellants. And so we can see the reaction down below here, and we're going to create nitrogen gas and water. And so the problem is telling us that we've got a fuel tank filled with 24 grams of hydrazine and 17 grams of hydrogen peroxide. So remember, we're going to go through the 4 steps. So the first thing we need to do is determine what we have in moles. The last problem that we did together said moles in it, so we didn't have to do any calculations, but this one only gives us grams. So what we're going to actually have to do is convert from grams to moles using the molar mass from the periodic table and also the mole ratio from the balanced equation in a little bit here. So first things first, I'm going to convert 17 grams of hydrogen peroxide into my moles of hydrogen peroxide. So, and this is going to be helping me determine what I have. So I'm going to start with 17 grams of hydrogen peroxide. I want to figure out how many moles that is. So I need to find out, well, what does 1 mole of hydrogen peroxide weigh? And so I can find that from the periodic table. If I add up the mass of 2 hydrogens and 2 oxygens, I get 34.02 grams of hydrogen peroxide for every 1 mole. Now notice, grams cancel. I'm left with moles, and that gives me 0.5 moles of hydrogen peroxide after I round. And so I'm going to do the same thing to figure out how many moles of the hydrazine I have. So this time I'm going to start with 24 grams of N2H4. I need the molar mass, so the mass of 1 mole, N2H4. And remember, I get this information from the periodic table, so 2 nitrogens plus 4 hydrogens gives me 32.06 grams of hydrazine for every 1 mole of hydrazine. And when you do the division, you get 0.75 moles of N2H4. So this is the amount of moles that I have. That's step 1. So in this case, remember, we had to convert to actually find this information. The next thing we need to do is figure out how much I need. In order to do that, I'm going to pick one reactant and determine how much of the other reactant I need to use in order to react it. So this time I'm going to pick the H2O2, the hydrogen peroxide. So I have 0.5 moles of hydrogen peroxide. And I am going to try to figure out, well, how many moles of the N2H4 do I need to react with 0.5 moles of the hydrogen peroxide? In order to do that, I need the balanced equation. So I'm going to go through and balance this equation. In order to do that, I need a 2 here and a 4 over here, and now my equation is balanced. So now I can actually use the mole ratio to convert from moles of this into moles of this, okay? Because remember, I'm trying to figure out how much of this do I need to react with this. So our mole ratio is a 2 mole of H2O2 for every 1 mole of N2H4, which means that I need 0.25 moles of N2H4. So I know what I have, I know what I need. My third step is to compare what I have to what I need. So remember, I calculated in my very first step that I have 0.75 moles. I calculated in my second step that I need 0.25 moles. In this case, I have way more than I need. I have got extra. So this is in excess, which means that the hydrogen peroxide is limiting. And so all the rest of the calculations then are going to be done with hydrogen peroxide because that was the one that's limiting. Remember, I can only make 7 sandwiches with my 7 slices of cheese. All the math has to be done with the cheese. So step 4 is to answer any of those additional questions. So the first question you're usually going to get asked is how many moles of product can actually be produced. So I'm going to figure out, except this time we're not going to do moles, we're actually going to do grams. So we're going to go all the way through. So I'm going to actually try to figure out, well, how many grams of this do I make and how many grams of this do I make? And so in order to do that, I have to use my limiting amount, 0.5 moles of the hydrogen peroxide. So we're going to go through and just do the simple stoich. So I'm going to start with 0.5 moles of my hydrogen peroxide. I want to convert moles of hydrogen peroxide into moles of N2. So I'm going to use the mole ratio from the balanced equation. Now my moles of hydrogen peroxide cancel. And now I'm going to convert moles of N2 into grams of N2. So 1 mole of N2 weighs 28.02 grams. And I got that from the periodic table. And now my moles of N2 cancel. And when you do the math, you get 7.0 grams of N2 gas is produced. And so I'm going to do the same thing with solving for water this time. Again, I'm going to start with 0.5 moles of my H2O2. This time my mole ratio is going to compare my hydrogen peroxide, which has 2 moles according to the balanced equation, to the 4 moles of water. And then I need to convert the moles of water into grams of water, and I know that for every 1 mole of water it would weigh 18.02 grams, and I would get that from the balanced equation, or excuse me, from the periodic table. Moles cancel, and when you do that math you get 18 grams of water. And so this is how much product I actually produce. And again, I found that using the amount of moles that I started with for my limiting reactant. Now, I'm going to do the same thing to figure out how many grams of excess reactant I have left over. So remember, this, my hydrazine, is in excess. I want to know, well, how much is left over? So remember, earlier we decided that if I have 0.5 moles of hydrogen peroxide, I need 0.25 moles of hydrazine. So 0.25 moles of hydrazine is going to get used up. But I started with 0.75 moles. That was from step 1. Oopsies. Oh, hold on, I'm not starting this thing over. You're just going to have to deal with it. Redo. Wait. Okay, we'll start again. So remember that when we figured out earlier, when we have 0.5 moles of the hydrogen peroxide, we are going to need 0.25 moles of our N2H4. And so 0.25 moles gets used in the reaction. But in our very first step, we said that, well, we actually have 0.75 moles. And so I'm going to subtract the 0.25 moles that we actually used to get 0.5 moles of my hydrazine. Oops, that's a 4. All right, but remember, I want to actually figure out grams, not moles. So we're just going to quickly convert 0.5 moles of my hydrazine into grams. So 1 mole of hydrazine, is going to weigh 32.06. Again, that's from the periodic table. And that's going to give you 16 grams of hydrazine left over. All right, I hope this was helpful. Thanks for bearing with the shutdown of my PowerPoint. Next thing I want you to do is work on the 4 problems in part 5 of your packet. The whole entire packet, the first 4 questions from part 3 and the 4 questions from part 5 are going to be due on Tuesday next week. If you need help, please come see me before school, after school, on Tuesday or Wednesday. All right, hope you guys enjoyed these podcasts. I miss you lots, and I'll see you on Wednesday. Bye.